Alright, let's do number 7. This is the last one I'm going to do for this unit, so you guys should be well equipped to finish up. Alright. One way to tell if a mosquito is about to sting is to listen for the Doppler shift as the mosquito is flying. Buzzing sound of a mosquito's wings is emitted at a frequency of 1050 Hz. If you hear a frequency of 1034 Hz, does this mean the mosquito is coming in for a landing, or that it has just bitten you and is flying away? At what velocity is the mosquito flying? Okay, so this is a cool one. I like this one because I hate mosquitoes. So maybe this way I can maybe avoid them or something. I don't know. It actually won't help me at all, but that's okay. So let's look at A. So the frequency of the object, or the actual frequency, equals 1050. And for A, the perceived frequency is 1034 hertz, right? So just like that video you saw where there's waves in the pond, and the distance between those waves depended on if it was coming towards you or going away. So if something's coming towards you bobbing up and down in the pond, the waves would be closer together naturally, right? Because they're going towards the waves, which is the frequency. If it's going away, the waves will appear further apart, which means this frequency is less. The frequency that you hear is less than the actual frequency, which means it's flying away. So that's a piece of cake. A is a piece of cake. We could do it. We could do the math and figure it out. But who wants to do that when you know the answer, right? I don't want to do the math. But you would get it. You would get a number, and that number would tell you it's going away. So let's go straight to B. Okay. What velocity is a mosquito flying? So, here we go. First, we'll do our formula. Perceived frequency equals actual frequency multiplied by the speed of sound plus velocity observer over speed of sound minus velocity of the, I got a brain fart, the S. Receiver, I guess. What am I doing? Why did I? Observer and, okay, I gotta look back because I forgot. What is the S? Source, there we go. Why did I forget that? It's getting late. I'm getting tired. Okay, so here we go. Let's plug in what we know. Cool, we know both frequencies. So the perceived frequency is 1034 equals the actual frequency is 1050 multiplied by the speed of sound 340 plus minus. Awesome. So we almost got everything we need. So what velocity is the mosquito flying? So the source we don't know. And the observer is not moving, right? Because it's just sitting there getting eaten. Or getting your blood sucked out. So the observer is 0. So now we're sitting on 1034 equals 1050 times 340 over 340 minus velocity of the source. Okay, so we didn't really do anything. We took away the parentheses and the 0, so that's good. That's another step, right? So now let's see how we can do it. Remember, it's this times this. So what we can do is we can divide out from the right side 1050. See ya. So now it's 1034 divided by 1050. And you should get about 0.98. 0.98 equals, so 1034 divided by 1050. 0.98 equals 340 over 340 minus velocity of the source. So now it's so far much more simplified. A couple ways you can do this. I will show you one way. So what we're going to do is we want to get rid of this on the bottom, so let's multiply this whole thing on the right by 340 minus velocity of the source. So that cancels out, boom. So now we have 340 minus velocity of the source times 0.98 equals 340, because that was the numerator, right? This stayed. This canceled out. This went to the left. This stayed. Okay, so now here we go. So 0.98 has got to multiply this and by this. So we're going to get 334.82. Can we still see? 334.82 plus this times this. 0.98 velocity of the source equals 340. It's a lot of numbers, but it's super basic Algebra 1, so fear not that hard. And you guys probably can do the rest from here, but I'm going to keep doing it anyways. Now, let's minus this over. Minus 334.82 cancels out. Minus 334.82. So now, I guess we got a little bit of space. We have 0.98 velocity of the source equals 5.18 meters per second. Let's start putting in units now. So 5.18 meters per second. Now we just divide by 0.98. See ya. Divide by 0.98. Oh. So now we have velocity of the source, aka the mosquito, should be about. Now for the key, they have different answers depending on if you rounded. I'm going to list them both. So you could either get something like 5.26 or 6.94. Like I said, as you guys know, you're in second semester physics. If you, that's 6 by the way. If you round early in the equation, when you do something, it can make an answer quite a bit different in the end. So this is our final answer. So I just want you guys to know that. So don't freak out if you're like, man, that's 1 apart. Why is it so far? You know, I got 6.94 and they have this. Why did I get that? Well, you know, if they rounded a little bit, even a number, a small number, they could get a little bit different answer. So if, as long as you got one of these, you're good to go. Okay? So either one's fine. That's how to do it. Awesome job.